Today I am going to do a questions which is from maxima and minima, and maxima minima. This topic belongs to applications of derivative. Now I am going to solve these questions by second order derivatives test, and problems is prove that the volumes of a largest cone that can be inscribed in a sphere of radius r. So in these questions we observe that the radius r, radius of a sphere is given, that means it is constant, and here we have to find the volumes is maximum. Now we have to prove that the volumes of largest cone that can be inscribed in a sphere of radius r. So a sphere of radius is constant. Now with the help of these questions we draw a graph. It is a circle. In the circles there is a cone. The radius of this circle is r. Here it is center. Now this one is radius, AO is radius, and QO is radius. Next, let CQ be small r and OC be small x. In these situations, the height of cone is r plus x. That means h is equal to r plus x. Now the volumes of cone. What is the volumes of cone? Cone is equal to 1 by 3 pi r square h. Volumes of cone 1 by 3 pi r square h. Now we observe that here r, small r, and capital small r and h, there are two variables, so we have to convert one to another. We have only one variables in this questions, in this expressions. So in right angle triangles OCQ, it is a right angle triangles. That means r square is equal to x square plus small r square. Here we find the values of r square. R square is equal to capital R square minus small r square. Now the volumes of cone pi r square h by 3. Now here the values of r square, we put the values of r square by equation 2, and the value of h from here, h is equal to r plus x. H is equal to r plus x, and small r is equal to capital R square minus x square. So P is equal to pi in bracket r square minus x square into x plus r whole divided by 3. Capital R is a radius of sphere, so it is constant, and only one x is variable. Now next step, we have to differentiate on both sides with respect to x. dv by dx, pi by 3 is constant, so it is outside. We apply derivative of product rules. Now what is product rules? If two functions are in this form, we have to differentiate both by x. Now u into dv upon dx plus v du upon dx. By this method we differentiate this one, we get this one. Now simplify it, we get this one. Again simplify it, we get this one. Now in next step we factorize it, we get r minus 3x into r plus x. Now for maxima minima, we know that dv by dx is equal to 0. We have to put dv by dx is equal to 0 for maxima minima. Now it is equal to 0, so here we get the value of x is equal to r by 3 and value of x is equal to minus r. But x is a distance, x is OC, x is a distance, and distance can't be negative. That's why it is not possible. So x not equal to minus r. So the values of x is equal to r by 3. Now again we differentiate this one. Again we apply product rules. We get a result, this one. Product rules: if two functions are in multiply formations, then first function outside second function differentiations plus second functions outside first function differentiations. So by product rules we differentiate this one. We get double derivative of volumes. We get pi by 3 minus 6x minus 2r. Now take minus common outside, minus pi by 3, 6x plus 2r. Now we know that x is equal to r by 3. X is equal to here r by 3. We put x is equal to r by 3 here. So r by 3, 3 2s are 6, 2r plus 2r, 4r, so minus 4r by 3, and r is constant, pi is constant, so resultant is negative. Since double differentiate is negative, that's why volumes is maximum for x is equal to r by 3. So we has a local maximum at x is equal to r by 3. Now what is the maximum volumes? So we have to put the values of x is equal to r by 3 in equations 3. X is equal to r by 3 in equations 3. Now simplify it. We get 8 by 27, 4 pi r cube by 3. Now 4 by 3 pi r cube is a volumes of sphere. So we prove that volumes of largest cone that can be inscribed in a sphere is equal to 8 by 27 volumes of sphere.